Okay, let's talk about negative exponents now. Any non-zero real number raised to a negative power is a negative exponent. To investigate the meaning of a negative exponent, we can simplify expressions like c squared over c to the fifth using two methods. So the first method, we're going to use the quotient of powers. This is similar to how we showed things with zero exponent. So 2 minus 5. Remember, you always have to do the top exponent minus the bottom one. Don't reverse it. So 2 minus 5 is negative 3. If you wrote it out, you would have 2c's over 5c's. 2c's would cancel. Now, be careful. A lot of people, whenever the numerator factors all cancel out, they would just write it, oh, that's c times c times c, so my answer is c cubed. But not really, because c divided by c is equal to 1. C divided by c is equal to 1. So you still have 1's in the numerator, okay, because you divided a number or a variable by itself. So it's actually 1 over c cubed. You can't just like magically get rid of the numerator, okay? So again, since c squared over c to the fifth can only have one value, you conclude that c to the negative 3 power is equal to 1 over c cubed. So for any non-zero number a and any integer n, a to the negative power is the reciprocal of a to the n. In other words, you drop it down to the denominator and write the exponent as positive. Okay? So 2 to the negative 4 is 1 over 2 to the fourth. Well, what happens if you have a negative exponent in the denominator? Well, you take the reciprocal of it and make the exponent positive. Okay, so here, 2 to the negative 4, you can think of it as 2 to the negative 4 over 1. You flip it over, and you get 1 over 2 to the positive 4. Flip it over, you change the sign on the exponent. That's kind of how you can think of those. Alrighty? All right, an expression is considered to be in simplest form when it contains only positive exponents. Each base appears exactly once, and there are no powers of a power, and all fractions are in simplest form. So let's simplify this expression and assume no denominator equals 0. Okay? So I can write it all out as separate fractions. N to the negative 5 over 1, p to the fourth over 1, and then since the r to the negative 2 is in the denominator, I can think of it as 1 over r to the negative 2. Then I can rewrite the negative exponents as positive exponents by taking the reciprocal of those ones. So this would be 1 over n to the fifth. This one, the p to the fourth, was already positive, so don't flip that bad boy. Okay? And then r squared comes to the numerator, and then you could just rewrite it as one fraction. Okay? All right, how about this one? Ooh, crazy stuff going on here. So you have 5r to the negative 3 t to the fourth divided by negative 20 r squared t to the seventh u to the negative 5. Okay? Now you can multiply it all out as fractions and group the factors with the same base. So put the r's together, the t's together, and this just has a u here. All right, so this 5 over negative 20, you can reduce that as negative 1/4. Now, this negative is not on an exponent. It's on the 20, which is not an exponent. So you wouldn't flip the fraction and make it positive. Don't do that. I've seen students do that. That's wrong. Okay? Use the quotient of powers property here. Negative 3 minus 2. That's what I got here. 4 minus 7. That's what I got here. And then I can just flip this one over since there's no u's to combine and make the exponent positive. So u to the fifth. So you'd have negative 1/4 r to the negative 5 t to the negative 3 u to the fifth. And notice we're almost done, but an expression is completely simplified when it contains only positive exponents. So I would rewrite the r to the negative 5th, t to the negative 3 as positive exponents in the denominator. And you would have negative u to the 5th over 4r to the 5th t cubed. I know, crazy stuff, right? All right, let's try this one. So let's group powers with the same base and the coefficients. So it's 2 over 10, a squared over a cubed, or a to the negative 3, b cubed over b to the negative 1, c to the negative 5th over c to the negative 4th. All right, simplify your fraction, so it's 1/5, and then subtract exponents. So a to the 2 minus negative 3, b to the cube minus negative 1, c to the negative fifth minus negative 4. See how your understanding of subtracting integers is going to be very helpful here. So you have a to the fourth, or a to the fifth, or excuse me, 1/5 a to the fifth, b to the fourth, c to the negative 1. Then your c to the negative 1, you can drop it down to the denominator, make a positive exponent, and your final answer is a to the fifth, b to the fourth, over c to the fifth. I know, pretty cool. All right, here's a couple for you to try. Go ahead and pause the video. Okay, we're back. So for a, what we're going to do is group. So you have v to the negative 3 over 1, w over w, x squared over 1, and 1 over y to the 6th. Okay, I can flip this one because there's no v's, so it's 1 over v cubed. W divided by w would be w to the 1 minus 1. This would just be x squared, and flip this one, y to the 6th. Okay, so it'd be 1 over v cubed, w to the 0, x squared, y to the 6th. W to the 0 is just understood to be a 1. So you would have x squared, y to the 6th over v cubed. Okay, each base appears only once, fractions are in simplest form, and each exponent is positive. All right, we're good on that one. Next one, got to group them. So 32 over 4, a to the negative 8 over a cubed, b to the third over b to the fifth, c to the negative 4 over c to the negative 2. 4 over 32 is just 8. So you have a to the negative 8 minus 3, b to the 3 minus 5, c to the negative 4 minus negative 2. So the 8, a to the negative 11, b to the negative 2, c to the negative 2. Okay? Then you can take the reciprocal of each of these and write it as a to the 1 over a to the 11th, 1 over b squared, 1 over c squared, which would be 8 over a to the 11th, b squared, c squared. Pretty cool, huh? I know, it's awesome. Last one here, you would have 5 over 25 times j to the negative 3 over 1, k squared over k to the negative 4, m to the negative 6 over m to the negative 2. This would simplify to 1/5. I could flip the j over, make it 1 over j cubed, k to the 2 minus negative 4, and m to the negative 6 minus negative 2. So I'd have 1 over 5, 1 over j cubed, k to the second, m to the negative 4, which would be 1 over 5, 1 over j cubed, k squared, 1 over m to the 4th. Put it all together, you'd have k squared. I'm sorry, that should have been k to the 6th. My bad. I didn't throw you off. K to the 6th over 5j cubed m to the 4th. I know you got to take a deep breath after you do ones like that. Pretty cool, though. Pretty cool. All right, last thing. Order of magnitude is used to compare measures to estimate and perform rough calculations. Order of magnitude of a quantity is the number rounded to the nearest power of 10. For example, the power of 10 closest to 95 billion is 10 to the 11th, or 100 billion. The order of magnitude of 95 billion is 10 to the 11th. Suppose the average height of a man is about 1.7 meters and the average height of an ant is 0.0008 meters. How many orders of magnitude as tall as an ant is a man? First, we must find the order of magnitude of the heights of the man and the ant. Then find the ratio of the orders of magnitude of the man's height to that of the ant's height. So I'm going to round each height to the nearest power of 10 and then find the ratio of the height of the man to the height of the ant. So the average height of the man is close to 1 meter, so the order of magnitude is 10 to the 0 power, because 1 is 10 to the 0 power. The average height of an ant is about 0.001 meters, so the order of magnitude is 10 to the negative 3. The ratio would be 10 to the 0 over 10 to the negative 3. So you subtract exponents, 0 minus negative 3 is 10 to the third, or 1,000. So a man is approximately 1,000 times as tall as an ant, or a man is 3 orders of magnitude as tall as an ant. So the ratio of the man's height to the ant's height is 1.7 over 0.0008, which is 2,125. The order of magnitude of 2125 is 10 cubed because it's a number in the thousands. All right. So the order of magnitude of the mass of the Earth is about 10 to the 27th. The order of magnitude of the Milky Way galaxy is about 10 to the 44th. How many orders of magnitude is the Milky Way galaxy as the Earth? So we're going to do Milky Way over the Earth. The Milky Way is 10 to the 44th. The Earth is 10 to the 27th. So it's 10 to the 44 minus 27. So that's 10 to the 17th. Okay, so it's 17 orders of magnitude. So the Milky Way galaxy is 17 orders of magnitude larger than the Earth. All right, pretty cool, huh? All right, guys, that's it for section 2. Please continue on to your assignment. And as always, reach out if you have any questions. Make it a great day. Take care.